First, see what is its time complexity. So first, let's see what is actually its time complexity. What is its time complexity? So the time complexity here is approximates equals to order of n log n. Order of n log n. So why these things? So n log n means this log n. This log n is responsible for range query. Okay, and this n is responsible for number of data points in that we have. This n is responsible for the number of data points in our data set. Number of data points or number of data points in our data sets, and this log n, and this log n is means we have to build a range query for each data points. So for range query we have already seen, well, for every step we have to find the core points for every step, to find the core density based point. Okay, so we have to run the range query. So this log n is means responsible for range query, region query, we can call it range query, or in another language it's called the, or to find the region query. We will see this thing. We have already seen one of our future video. We will see how these data structures are actually, KDTD data structure actually used to build this query. We'll see this thing. QUE, I think. Range query. These things have been built by simply using KD tree. By simply using the KD tree, this range query has been built. We'll see. So the advantage is here. Just if you remember, for K-means algorithm, the time taken, its approximates equals to order of n if the dimension of our data is very less to our number of data. We have seen means it's the linear time complexity in hierarchical clustering. In hierarchical, we have seen in hierarchical clustering its time is order of n square log n square log n. Okay, or if we have some complex data structure we will use, if we have used, then we have seen it's order of n square or order of n cube. This much means it's not linear, simply it's the quadratic time, almost quadratic. Almost quadratic time complexity is had. But the advantage is for DBSCAN, the time complexity is not linear but not quadratic as well. So this is the in middle, in between this. So the time complexity is, it's not linear, but sometimes good. This one is okay, not something but almost linear, we can call these things. It is the almost linear. These things is almost linear. It's almost linear. Okay, so these are the time complexity because of this thing, because of the n log n, because this n is for number of data points, and for each data points we have to run the range query, and the range query time it's taken for its log n. We'll see these things in one of our future video. For the data structures KD tree actually used to build this range query, we'll see this thing. But these are the time complexity actually. Means these are the advantages. It's something better than the hierarchical clustering, and it's almost it's almost linear. Means the the k-means algorithm we have seen is the linear time complexity, but it is almost linear time complexity for DBSCAN. Now let's see what is its the space complexity. Let's see what is its space complexity. Complexity. What is its space complexity? Let's see. The space concept complexity is almost approximately is equals to order of n. If our dimension is less than very less than the number of data points. Okay, so because why these things, order of space complexity is n, order of n, because its space complexity is order of n, because the space complexity here is order of n, because we have to store its data points into our databases. We have to store the data, to store the data into our databases. It may be Oracle database or it may be a MySQL database. So at the end of the day, for these DBSCANs, we have to store the edge data points into our databases. Store the data into databases. Because of that, its space complexity is order of n, and we have to remember that the DBSCAN's algorithms are actually built by the database community scientists, database community or data mining, and the data mining community. Using these two community, these algorithms have been built actually, because of it's the most advantageous part of its time and space complexity. So so we have seen that the time and space complexity is reasonable well. Okay, it's well. The main disadvantage here is it's the very sensitive to our. This is the main advantage. Unless it's everything is okay, the algorithm it is very sensitive to the noise. It is very sensitive to noise. It is the main disadvantage. Unless everything is okay. So it's reasonable well, its time complexity is reasonable well, means it's almost linear, and also space complexity is also linear. Just we have to store our data number of data points into the databases. So because of that, its space complexity is order of n, and its time complexity order of n log n. It's fairly well for the hierarchical clustering, because in hierarchical clustering we have seen it's almost quadratic time complexity it has, but here it's almost linear. Okay? But the KD tree, the k-means algorithm, we have seen its time complexity of linear, but the main problem is it cannot handle different sizes of data, different shapes of data. But the things, the DBSCAN's algorithms are doing very well. It can cluster properly very well in different shapes of cluster, different complex shapes of cluster. It can doing the job very well. But the k-means algorithms are failed. Because of these reasons, DBSCAN algorithms are more preferred in sometimes. So at the end of the day, we have to see our requirement. What is our requirement? In which situations, in which environment we are going to build our model. So that's the main thing. And based on this requirement, these situations, these databases, we have to choose the algorithms. Which algorithms will be better for us, and which algorithms at the end of the day we have to use for better output. So that's totally depend on our situations. It can depend on our problem. So the first thing is we have to understand every problem deeply. Then it's possible to apply which problem will be fit better on that situations. That's the first thing in every machine learning algorithm. In every machine learning, when we'll discuss the case study, step by step, then we'll see in which situations which kind of algorithms we have to choose. We'll see this thing.